Hey guys, welcome back to the next video. In this video, we are going to understand about OpenShift Kubernetes overview. Now, we are going to talk about some of the features which we discussed on the previous video. We're going to look at in each feature and going to understand about that. So OpenShift is nothing but Kubernetes plus enterprise features. So basically, it provides a complete platform for running containerized application, and that's all about it. Now let's talk about some of the features in Kubernetes. Now, one of the service of which we have seen as a feature is service discovery and load balancing. Now, using this, you can access application using service names. Kubernetes distributes traffic across different pods. And the live example is like you can create a load balancer traffic with the name of loan-service. And that would be the name of your actual service over here. So this is basically how service discovery and load balancing works on Kubernetes. The next feature, we're going to talk about horizontal scaling. So what this means is that auto scales pods based on the load. Now it could be a CPU memory load on the system. And basically what this means is that for an example, you have 2 pods running and then the load on these 2 pods gets increased, and then the number of pods increases based on your customization. Let's say, for example, you get maximum of 10 pods running during the peak traffic. The next item is self-healing. In the self-healing, we have something called restart failed pods, where it restarts the failed pods. It moves workload if the node fails. A node, as I told you, is basically the server. And for an example here, when an app crashes, it automatically restarts the container inside a pod, or the pod itself. What I meant to say, the pod itself. If a container fails within a pod, it basically restarts the pod itself. The next feature is rollout and rollback. So there is a feature of gradual updates, rollback on failures. For example, if you are releasing a new version and it fails, it basically reverts back to the previous version of application. The next one is secrets and configuration management, or config management. Now here, secrets helps you to store sensitive data securely. For example, if you have data like username and passwords, SSL keys, any kind of certificates like keys and key and key password, those can be stored as part of secrets and then can be called via pods. So rather than directly or hard coding and exporting this into the pod configuration or your containers within the pod, you basically can import a secret which is stored in the OpenShift and then basically call that upon your application, which is residing inside a container on a pod. Now this is a feature on Kubernetes as well. Like for example, database passwords stored in secrets can be retrieved directly by calling that. Other than that, if you have an environment variable, if you have any kind of a variable which needs to be exported as part of container, you can store it in the config option. So config is basically something which doesn't require a password or like a security. Secrets are something which requires security. The next one is operators. So this basically automates application lifecycle, like example, database auto installation, backup, scaling, all these can be imported as operator, which is like third-party updated ones. Now you also have OpenShift developer workflow where you can build, store, deploy applications, UI, CI/CD pipelines, registry, and S2Is. Like for example, git push to auto deploy. So this is all part of the developer workflow. And also you have observability as well as part of the feature where you have monitoring and logging, like detecting CPU spikes, failures, and understanding your application much better using observability. The next one is server management. So it uses core operating system, core OS, which is from Red Hat Enterprise Linux. And also you have automated updates and no manual patching. So it's all automated patching as well. And in terms of OpenShift architecture, you have OpenShift layer, Kubernetes layer, container runtime environment, CRI-O, which is a software which is used for container runtime. And then you have Red Hat Enterprise Linux Core OS, and then your infrastructure. It could be a virtual machine, it could be a physical machine, however it is. It can be a server which is hosted on AWS as well. So this is how the OpenShift layer looks like. As you can see that some extra features have been added over here, enterprise level features, but the base here is Kubernetes and the container base is container runtime using CRI-O. So this is where we will be using Podman, Kubernetes, and then on top of OpenShift. So Podman, kubectl, OC. So these are the commands which we will use on each layer. So advantage of OpenShift, it is managed versus self-managed. So one of the items here is like when you talk about managed, it's easy and it requires less control. Self-managed, on the other hand, gives you full control, more responsibilities. So that's all I have for you in this video. I'll see you in the next one.